Hi, Mark.
Hello, very nice to see you.
Hi, see, nice to see you. I think this is my first time to see you, right?
I think so. I don't think we
Yeah,
met before.
yeah. But from Rachel, I was the topic is so interesting. Yeah, I think this is something new to us. So everybody, I think most of those who attended this is our former students. For me and mine and Pak Iskandar. So I think they are really interested in these topics. This is something new because the word Anthropocene Biosphere itself is quite new to me. So I'm really looking forward to it. Yeah.
Not so new to me.
When I first met Rachel, I thought maybe we are like how to say, like somebody who is digging for dinosaurs or something like that. But it's offline.
I like to dig for more recent stuff.
So yeah, so I think I will not talk too much because your topic is so interesting. I think I will start the lecture. Maybe perhaps with Professor Mark William first. Maybe you can introduce Rachel's work. What is this all about? And then Rachel later will explain more detail about it. So time is yours, Mark. Please.
Okay, good. Okay, I'm going to give you an introduction really to the more detailed work that Rachael is doing in Indonesia. My name's Mark Williams. I'm a professor at the University of Leicester, and I've been working on the Anthropocene for about 15 years now with my good friend Jan Zalazevich here. I think Jan and others may be watching from Leicester as well. So the Anthropocene Biosphere, really this is about the way in which humans have very fundamentally changed the Earth system. So I want to give you the context for the degree of change that we've made with the planet, which will set up what Rachael will say more specifically about Indonesia. So as a geologist, I study how the Earth system has changed over many billions of years. And obviously the Earth has gone through many different transitions from an early Earth with no life, through an Earth state where it's been encased in ice, a snowball Earth, and it's evolved eventually to this beautiful blue planet that we live on. But now we can perhaps say that the impact of humans as a species means that it's evolving to a new state, that we can actually call it human planet in terms of our impact. And I'll try to show you why we think that's the case. Because the world is changing very fast now. I often use the analogy of visitors from outer space passing on the dark side of the Earth. And if they look at the night sky, they would have seen something very, very fundamental changing over the past 200 years. Because the night sky, of course, now is ablaze with the lights of many cities on this planet with more than 1 million population. And you can see Java down there, I think, very, very bright at night. So why do I say that, or why do we say that humans are fundamentally altering the Earth state? Well, if you look at the way that we move Earth, sediment, around the planet, then it's an order of magnitude greater than the movement of sediment by all of the rivers on planet Earth. There's an incredible amount of sediment. 150 cubic kilometers of sediment is moved by humans each year, which means that we are geological agents. We also use an incredible amount of water. 10,700 cubic kilometers of fresh water is utilized by humans every year, or 29 cubic kilometers per day. Or we could drain Lake Toba in Sumatra dry every 8 days from our water usage, which is an incredible thing to think about given the scale of that lake. We also changed the atmosphere. Last year we put another 38 billion tons of carbon dioxide into it. So we're fundamentally changing that component of the Earth system too. And we fundamentally change life. A recent report has suggested that as many as 1 million species may be at risk of extinction on this planet, so that we're moving towards a state where we may precipitate a mass extinction event. Those are something obviously that geologists have studied in very great detail in their deep geological record. We consume vast amounts of energy. something like the order of 900 exajoules of energy a year. And that figure for me is an impossible figure. I can't really understand what that is. So I tried to break it down into a smaller kind of component. So if you were to take an old style 60-watt light bulb, to burn through 1 year of human energy, the light bulb has to stay lit for 450 billion years, which is an incredible amount of time, much more, of course, than the age of the universe. Why do these changes have such big impacts? They have such big impacts on the Earth system because the Earth system, the atmosphere, the oceans, the land, and life are finite. They're actually quite small. So here, I'm using a wonderful image from the artist Adam Neiman. And you can see that Adam Neiman has collected all of the Earth's water from the oceans, gathered it up into a single ball, and he's gathered up all of the atmosphere also. And in this scale, you can see just how small they are, just how finite. So of course, relatively small changes induced by humans can have a very significant very significant impact on the atmosphere and the oceans. And these, of course, are our life support systems on planet Earth. When did humans begin to dominate the Earth system? So when did we start to become really, truly global agents of change? This is a pattern, of course, which has been unfolding for a very long period of time, really since the first humans picked up stone tools to manufacture them from about 3 million years ago. Gradually over time, our impact has been increasing, but really the very, very substantial changes are those that occurred in the 20th century. If you look at different parameters, for example, if you look at the way that we've emitted carbon dioxide to the atmosphere from the burning of fossil fuels, 85% of those emissions to the atmosphere are since 1950, so since the mid-20th century. And you can look at a whole range of different parameters. This is a paper that we published a few years ago as part of the Anthropocene Working Group. And looking at different parameters, nuclear parameters, for example, the radiogenic isotope signal, or the cumulative production of concrete or plastics, or the burning of fossil fuels. All of these give very, very distinctive signatures of fundamental change and a fundamental acceleration in our utilization of resources from the mid-20th century onwards. And all of those also dovetail with our use of atomic weapons. And the detonation of atomic weapons, beginning in 1945, has also left a very distinctive geological signal of radioactive isotopes that we can recognize in lakes, in marine sequences, all around the planet. So again, this has given us a very distinctive geological signal that we can look for. So this is the geological timescale. It's a timescale which we've been evolving over about 200 years. And it's showing you the enormity of geological time going back over 4 billion years. Each of these subdivisions represents something very substantial. If you look over to the very far left of the figure, and at the very top, you'll see the Holocene epoch of geological time. So that's the last epoch that we measure. It's the time when the Earth transitioned from a glacial state to an interglacial state. We would now argue that the degree of change induced by humans to the planet and the geological signal that that's left is sufficient that we should now designate a new time interval here, an Anthropocene epoch. And that's what we're working together as a group to try and define. And Rachael's work in Indonesia is very, very important in this context also, to look for the Anthropocene signature in Indonesia. So it's this overall signal that she's seeking to identify, the level of the Anthropocene where you can recognize this fundamental shift in the Earth system. Now, that's one part of Rachael's project, but there's another side also. So Rachael wants to establish the stratigraphy, the horizon in the sedimentary succession where you can recognize the Anthropocene, but she also wants to measure the Anthropocene impact too. What is the human impact? How can we measure that impact? We can measure it globally. We can measure it, as you'll see, in Indonesia too. So if we think about humans as living organisms, there are 7.8 billion of us on the planet at present. Very soon there'll be 8 billion of us, and soon after 9 billion of us. If you take Jakarta, it's the second largest city on the planet. As a mega city, 33 million people. I can't really imagine that. I know Jakarta well, but I still can't imagine what 33 billion people looks like, because it's obviously a vast number of people. Let's take this down. Let's break it down a little bit. Let's come down to the population of Bogor, where EPB is. That's around about 1 million, but of course it sits within that broader context of the Jakarta megacity. Still a lot of people to try and imagine what that looks like. So I'm going to bring it down a little bit further to the small town of Huatas in Kulon Progo, which again I know very well because my partner, my wife, is from Kulon Progo. It's about 44,000 people in Huatas. Now I want to give you a comparison with other primates, with other apes and monkeys that we're closely related to. How many villages and towns in Indonesia will non-human primate populations make? Let's have a look at some of the very famous ones. So there's the Bornean gibbon. There are about 400,000 of them in the wild, so that's half the population of Bogor. And then perhaps the most iconic primates of Indonesia are the orangutan. The Bornean orangutan, about 50,000 maybe in the wild, so that's the population of Huatas. The Sumatran orangutan, about 7,300, and the Tapanuli orangutan, only about 800. So the Tapanuli orangutan is one small human village in its total population. And the point of showing you this is that humans are numerically more than 99.9% of all primate individuals on this planet. We are completely dominant. We dominate all of the primates. That population has been going up very fast. I was born in 1965. Since I was born, the population of planet Earth has more than doubled. And that doubling has had a very, very substantial impact on the biosphere. And it's these changes, again, that Rachael is going to emphasize to you in an Indonesian context. But I just want to summarize the 4 truly unique changes that humans have induced to the biosphere over the past century or so. There are 4. Let's start with the first one. This is the huge energy resources that we take from the biosphere. So you can see the figures there that humans and their domesticated animals are about 175 million tons of carbon by dry mass, whereas all wild mammals are only 5 million tons. So humans and our commensal animals are 95% of all land mammals. But it's not just that we dominate the land, we also dominate the oceans. Again, if you look at the figure on the bottom left there, you'll see that in 2016, which was the peak of our fisheries, we took 171 million tons of fish from the oceans, and we wasted about 25% of that. They didn't actually get to human consumption. The second change is the way in which we have relocated species around the planet. So that could be your pet cat. Of course, it could be a whole host of other species because there are tens of thousands of these relocated species. And again, Rachael will talk about this in a lot more detail. This is just showing you species invasions of vascular plants, of land plants. And you can see that this is a global signal. And this is unique. We do not see a global signal like this in the geological record before. And this global signal can only be induced through the actions of humans transporting animals and plants around the planet. It's smearing the biogeographical boundaries that we're familiar with for over a century, that great scientist Wallace recognized, first of all, in Indonesia with the Wallace line. Those geographical boundaries, those biogeographical boundaries are being smeared. So that now if you look at Indonesia, you can see all these different biogeographical boundaries. And again, Rachael will talk about this in much more detail. Here we have the golden apple snail, which was being introduced from Argentina, and it's completely rampaged across Indonesia. It doesn't really care about these biogeographical boundaries, and that change is a result of human actions. Even geographically remote islands are invaded, Hawaii too. So we have the Pacific rat introduced to Hawaii about 1,000 years ago. And then we have in the 20th century, the giant African snail and the cannibal snail. And these have had a major impact on the local Hawaiian fauna and flora. So here you can see a stratigraphy. You can see the indigenous snails of Indonesia at the bottom. And at the top, we have these introduced snails. And now the indigenous snails are extinct. So a very, very distinctive signal. Again, it's this kind of signal that Rachael is looking for in Indonesia. Change 3 is the way in which we've modified landscapes, the way in which we have anthropocized humanized the landscape. Here I'm using the work of Earl Ellis, who's a scientist at the University of Maryland in the US. And Earl has tried to quantify how we've changed the landscape over the past 300 years. So here you can see the planet in 1700, and some of the landscapes are used, they're altered by humans. Just have a look at Java in the bottom right there as we go forward 300 years. And you'll see that now effectively all of the landscapes of Java are effectively used or modified in some way by humans, as of course are the landscapes of the UK where we're speaking from. And this is very significant because what we can say is that the world is no longer dominated by natural ecosystems, but in fact is dominated by human systems with remnants of natural ecosystems embedded within them. The final change I want to talk about is the technosphere. This is the idea of Peter Haff at Duke University in the US, again, along with Jan and I and many others. Peter is part of the Anthropocene Working Group. This is the way that humans have developed systems, technological systems, social systems, political systems that connect us together. And this mechanism now is what binds us together and allows us to have the complex kind of interconnections we have as a species. But it's also an incredible consumer of materials. So if you try to measure it, the physical technosphere, it is huge. It weighs something like 30 trillion tons. All our urban areas, our pasture lands, the trawled seabed, croplands, roads, reservoirs, railways. It's vast, it's huge. It's a sphere in its own right. It covers the whole of the earth. And it consumes at an incredible rate. Just to give you a figure of cement consumption here, you can see that China consumes as much cement as the USA consumed in the 20th century in a few years. That's how fast this system is accelerating. It's accelerating so fast that our patterns of human consumption now resemble those of a parasite rather than the more mutualistic relationships that allow the biosphere to persist over very long time frames. If that pattern continues to develop, of course, then we will have negative feedback mechanisms kick in, the accumulation of pollutants like atmospheric CO2, the accumulation of plastics at the surface. This will have a significant effect on humans also. Ice sheets will melt and sea level will rise. And this too is very important for Indonesia because there are about 1.4 billion people living in a low elevation zone near the sea that are susceptible to sea level change. And Indonesia is one of the key countries here that has the greatest exposure to this. So I'm about to finish now and I'm about to hand over to Rachael, but I just wanted to leave you with two scenarios, two likely outcomes of the near future as a prediction from a geologist who studies the deep past. If we carry on with our business as usual relationship, if we continue to consume in the way we do, then human changes to the biosphere will become unsustainable and we will make a mass extinction. I think that's inevitable within a couple of centuries if we carry on. So what we have to do, of course, is to change human behavior. Humans need to evolve a more mutualistic relationship with the biosphere, and this will then be sustainable over long periods of time. But even in that second case, we will have changed the Earth system so fundamentally that from my perspective, from Jan Zalazevich's perspective, from our colleagues on the Anthropocene Working Group, we would still say that we have transitioned into a new epoch of geological time.